Hello, today we'll start the new unit, that is third one, and the name of the unit is Thermal Properties of Solids. The unit specially dedicated to the specific heats of solids, and that is what the very first article we are dealing with. The name of the article is Specific Heat of Solids. We are familiar with the specific heats of gases, and similarly we can define the specific heats of solids also. So as the first sentence mentioned here, the heat required to raise the temperature of 1 gram a molecule of the substance through 1 degree centigrade, that is called as specific heat of the solid. That means the amount of heat required to increase the temperature of 1 gram molecule of a solid through 1 degree centigrade. That amount of heat required to increase the temperature by 1 degree centigrade of 1 gram molecule of a solid, that is called as specific heat of the solid. Let us see how mathematically it can be interpreted. For example, if dQ is the amount of heat added to raise the temperature of a substance from original temperature T to T plus dt. That means here the temperature is increased or raised by amount of dt. Okay. In that case, the ratio dQ by dt that is simply called as specific heat or specific heat of the solid. We can mathematically represent C equal to dQ by dt as the specific heat. Now, important thing is that the dQ, that is the amount of heat added, it can be added under different conditions, and accordingly different types of specific heats exist. For example, if dQ is added under the condition that pressure remains constant, then we obtain a specific heat at constant pressure. On the other hand, if dQ is added to the substance by keeping its volume constant, then we obtain the specific heat at constant volume, where the relation between specific heat at constant pressure and specific heat at constant volume, that is Cp and Cv, is that Cp is always greater than Cv. Okay, now let us recall the first law of thermodynamics, and according to first law of thermodynamics, the heat added to the system, it utilized by the system in two different ways. That is utilized to increase the internal energy of the system, and second, to do some work against the external pressure. In this way, if dQ is the amount of heat added, then it can be expressed as dE plus PdV, where dE is the increase in the internal energy and PdV represents the work done against increase in volume or change in volume dV against pressure P, against external pressure P. If the heat added to the system at constant volume, then dV is equal to 0. If there is no change in volume, then dV equal to 0. And you will find that the second term PdV that will, in the equation 2 vanishes, and we will obtain dQ equal to dE. And in this way, if we substitute dQ equal to dE in equation 1, we find that Cv, that is equal to dQ by dt at constant volume, because here volume is constant. So we put here V as a subscript, and dQ is simply equal to internal energy, because PdV, the term that vanishes, so dQ equal to dE, and hence dV equal to dE by dt at constant volume. So this is about the specific heat at constant volume. Now what will be specific heat at constant pressure? That will be dQ by dt at P, at constant P. In case of gases, there is a large difference between the two specific heats, Cp and Cv, and Cp is always greater than Cv, and the difference between Cp and Cv is written as Cp minus Cv equal to capital R, where R is the universal gas constant. But in case of solids, Cp is nearly equal to Cv, particularly at low temperatures. Therefore, a common term, that is specific heats of solids, is used besides using specific heats at constant volume and specific heat at constant pressure. Okay, so since there is no change in volume, so almost all heat supplied is to the solid is utilized in increasing the internal energy. In case of gases, we have seen that the volume has been changed, but in case of solids, there is very minor or there is almost no change in the volume due to application of heat. So therefore, the PDV work done is 0, and therefore almost all supplied energy heat dQ is utilized in increasing the internal energy dE. So dQ is equal to dE. Okay, and the increase in internal energy that occurs in case of solid in two ways. Due to increase in internal energy, one kind is that atom vibrates rigorously, and another part of internal energy appears in terms of free electrons which gets thermally excited, and they get excited to higher energy state. So in this way, internal energy, increase in internal energy appear in two different forms. One is increased vibrations of the atoms, and another is the increased energy of atoms due to, increased energy of electrons due to which they excited to the higher energy states. The first contribution, that is the increase in vibrations, that is called as lattice vibrations. Okay, and the second one is related with the energy of the electron, and that is called as electron or electron specific heats. So in this way, specific heat of solid has two contributions, that is lattice specific heat and electronic specific heats. In the next coming, we are dealing with next coming articles, we are dealing with the lattice specific heats. Thank you very much.